So hello everyone, welcome back to the channel. Today we are going to solve the problem special digits. So you are given 5 integers n, a, b, c, d. Let's say all integers of length n having only a or b in their decimal representation are good integers. Also, among all good integers, all those integers whose sum of digits contain only c and d are best integer. So find the number of best integers of length n. Since the number of best integers can be huge, print it modulo 1 in 9 plus 7, 10 to the power 9 plus 7. Okay. So let's understand the problem with an example test case. We have n is equals to 3. So let's generate the good integer first. So before understanding the question, let's go up with me. We have n positions. Okay. We want that within them only 2 and 1 are allowed. Nothing more than allowed. That means what I want permutations of 2 and 1, A and B. Okay. Permutations of A and B. Okay. So that means what are the permutation of A and B? What are the permutation of A and B? Let's say I have 2 and 1 and I want 3 digits. So 1 2 2 2 1 2 2 2 1 and or what we can have 1 1 2 and 1 2 1 and 2 1 1. I know like this and 1 1 1 and you can have what more than that? No, or 2 2 2. Yes. Okay. So these are the permutations that you can generate using 2 and 1. Okay. And these are 3 digits only. Okay. Now, the question is, let's sum up. These are good integer. Now, let's generate the best integers. Okay. Let's sum all of them. 5, 5, 5, 4, 4, 4, 3, and 6. Okay. Now, now within them, I want only those integers that contain only 4 and 6, C and D. That means I have 5. No, no, no. Yes, 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 no, yes. Why? Because we have 4. 4. So we have 4, 4, and 1 is 6. Okay. So this is a question. Now what I want that the numbers best integer are those numbers which on summing when I sum the digits of the good integer, they will generate some number and these numbers should contain only these 4 and 6. Okay. Now you will ask like this is equal to 4, not contain. So what do you mean by contain? Contain is something like if I take big example and let's say I got the sum here like 4 4 6 6. Okay. So this contain only 4 4 4 6 6 and this is C C C D D. Okay. Now let's say I got this 4 4 4 5 6. Now I can see 4 4 4 is here. Yes, this is C C. This is D, but this is not. This is nothing. I have nothing like 5 here. I have two only variables C and D, and only that should be there. This 5 should not be. So this is not a what best integer. So best integer are those integer when I sum the permutation, when I sum the digits of the permutation generated and the sum that I got should have only C and D. Okay. So this is the question. Okay. So now, how can we approach this question? So we will not jump directly to the intuition. So just dry run the approach and we side by side get the intuition. Okay. So now let's consider example test case. N is equals to 3, A is equals to 2, B is equals to 1, C is equals to 4, and D is equal to 6. Okay. Now, this is the example test case. Now, first, our work is generate good integer combination. What are good integer? Permutations of A and B. Okay. But I don't want any arrangement. That means, so let's try on the approach you will get. Okay. Now, let's say I have one A. Then, since I want 3 integer, then rest of them will be B. Obviously. Let's say I have 2A. Then rest of them will be B. Let's say I have 0A. So let's add this 0 variable A above. Let's say I have 0A. Then B, B, B. And let's say I have 3A. Then no B will be there. Okay. So now these are the combinations that I can check. So when I rearrange this will be B, A, B, 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 A. Similarly, this can be A, B, A, B, double A, Similarly, this will remain A as is because no more arrangements can be done. Similarly, this will remain BB as it is. So in total, I have 8 permutations that I can generate, but I will not take all of them. So what I will do, let's see. Let's proceed side by side that what I will be going to do. I have generated combination. That means currently I'm not considering the arrangements that I created. Okay. So let's consider like these three B's. So let's add these three B's. 1, 1, 1. So this is equal to 3. Now we have done this step that we are generating BB, ABB, AAB, and AAA. So now I have written directly the BBB and AA. Now let's write in the form of variables. Now I have written initially BBB, that means 1, 1, 1. Next time 1A and 2 B's. 1A and 2 B's. That means 1A, here I will take A. So this will be 2. 2 B's 1, 1. Next time 2, 2, 1 and 2, 2, 2. So I have taken only combination, not arrangements currently. That means I can rearrange like 1, 2, 1, 2, 1, 1, 2 and anything. Just don't think about that. Just think like this only. Okay. Now, my next task is to check if it is form best integer. Now, what I will do, I will add all of them. As I said, for making the best integer, I will add all. Now, when I add all of them, this will be equal to 3, this will be equal to 4, this will be equal to 5, this will be equal to 6. Okay. So now check. Now check whether it contains C and D only. No, it contains 3 as well. Skip. Skip. Now, whether it contains C and D only, yes, it contains 4 only, and which is only within C and D. So I will say, okay, that means if this can give 4, that means its permutation can also give 4. 1, 2, 1. This can also give 4, now this will be equal to 4, this will be equal to 4. That's why I only consider combination. By considering only combination, I will try to get all the arrangements answer. Okay. That means if I got that, if I got that at 2 plus 1 is equal to 4 and it contains only C and D. So I will say that these all arrangements will also give me 4. Okay. Now question is how to get these arrangements. So now you can see that, well, now we have three variables, 2, 1, 1, and total number of element is 3. Now, as you studied in 11th class or you don't know, so let me tell you, what is the formula of permutation, getting the arrangements. For getting the arrangements, we have to take above n factorial divided by number of distinct elements. Let's say I have one element. So let's say I have 3 elements in total. So formula will be 3 factorial upon distinct element will be 2 factorial. 2 elements are here, same. And 1 element is here, same. Okay. So let's say I have 2, 1, 1, 3. So what I will do? 4 factorial, 4 elements. 1 this element, 2 these elements, 1 this element. So this is a formula of generating permutations. I hope you get this formula. Okay. So similarly, here what I will say, yes, this is a formula of permutation. So what I will do, since this gives me correct answer, so I will say we can have how many arrangements? 3 arrangements. How? What I will do, 3 elements, 3 factorial upon 2, 1, 2 factorial, 1, this. We will make the grouping and this will be equal to 3. Okay. So I got answer as 3 currently. Now let's go to next. Here the sum is 5. So can this be best integer? No. No. Here the sum is 6. Can this be best integer? Yes, because it contains only C and D only. So I will say okay. Number of elements are 3. Number of similar elements are 3 again. And we have no one currently available, so it will be 0 factorial. 3 factorial upon 3 factorial. 0 factorial is obviously 1. 3 factorial and 3 factorial will cancel out and this will be 1. So here answer will be 1. So 3 plus 1 is equals to 4 and this is my answer. So, so what is the intuition that you got side by side? That we will generate the combinations and when I sum them, so other arrangement will also give me same sum obviously. If I have 2 to 1, let's say I have 2 to 1, then it will also give 1, 2, 2. It will give 5, it will give 5, it will also give 5 because digits are same now currently. Digits are already same. Just we are rearranging. Okay. So if I get only for combination, then I can get for all permutation as well. Okay. Now, by doing the sum, we check whether it contains all the digits, only C and D. If they are only C and D, then it is a good. Just get their permutation. Otherwise, not good. Don't get the permutation. Okay. So let's see the implementation part. So first implementation part is that we were doing 0A and like let's say I have n elements. Okay. Let's say I have n elements. So what I was doing, I was entering combination like I have 0 A's and n minus 0 B's. Rest of the element is B's. 1A, n minus 1 B's. 2A, n minus 2 B's. So how can I process? I will just use a for loop. I is equals to 0 to n and I will say, okay, what will be the sum? What will be the sum of digits? Like we have 1A, 0A. So no 0 will be there and all the B's will be there. So if I add all the B's, we have n B's. So we will just do n into B. Now, similarly, since we have 1A here, we can have 1 into A plus n minus 1 into B. This is the sum. Why? Because A plus B plus B plus B n minus 1 time. We will just multiply n minus 1 into B. Okay. So this is the approach that how can we get these combination. So I will say sum is equal to what? I into A plus n minus I into B. In this way, I will be get the sum. Now, how can I check whether it contains C and D? So this is a good integer. Now, how will we check whether it contains C and D? So just normally, we will check that we will check the remainder for every element n modulo 10 and divided by 10. We will check whether remainder is equal to is not equal to C and remainder is not equal to D. That means if it is neither C nor D, if it is neither C nor D, that means it's not a good element. Just break out. Just break out. If it is, if it is, then what I will do? I have to get the permutations. Now, how to get the permutation? Answer plus is equal to, let's say I have NCR function, which give me permutation. Okay. Now, our main task is to generate NCR function. Now, what is NCR function? As I said, let's say I have A, B, B, B. So what is NCR function? 5 elements, 5 factorial upon 2 factorial upon 3 factorial. Okay. So what I will say, if I'm sending I, that means I have total n elements and I is. So obviously n minus I b's as I was generating 0A n minus 0B, 1A n minus 1B, 2A n minus 2B. So I will say, let's get the all the permutation n factor using this formula, as I already said. Here comes a competitive part. So this question is somewhat competitive. That's why it's hard question. Now, because we are doing modulo mode, then what happens? Let's say I have numerator and let's say I have denominator and I do modulo mode. So what happens? Numerator, we can't write like this numerator modulo mode and divided by denominator modulo. Rather, we should write it as numerator modulo mode into denominator denominator power mod minus 2 modulo mode. Okay, this is the formula. This is like in the competitive Fermat's little algorithm. Like within that Fermat's little theorem. So within that we learned that whenever any number is in division, we write is as base and mod minus 2 as power, and we will do modulo mod. Okay, so this is what we have to achieve. Now this is a factorial that we get using the factorial function. So let's better understand by writing the code. Okay. So the first question is we have to generate all the permutation, combination and store and check whether it is a good integer or not. So I will say, okay, start from 0, I less than is equal to n. So what is I depicting? Number of A's. What is n minus I depicting? Number of B's. Okay. Now, so sum will be equal to number of A's plus n minus I into B's, as I already said. Now, let's consider this is a good value. This is a good number, good integer. Uh, since it is best integer, let's say. Okay. Now we will say, okay, let's check whether it contain only C and D. If it contain any element which is not C and D, this is wrong. So we'll do int remainder is equals to sum modulo 10. And if remainder is not is equals to C, and if remainder is not is equal to D, I will say good best is equals to false, and just break out that this is not a best integer. And sum divided by 10, if it is not, just go ahead. Okay. Now I will say if it is a best integer, then what I will do? I will add all the permutations of this NCR. We will create a function NCR, let's say. N comma NCR is actually a mathematic thing. So if you know this, you will get that modulo mod. Okay. Because answer can exceed it. We have already said we have to do modulo mod and add then return answer. Now our main aim is to generate NCR. What is NCR? As I already said, this is n factorial upon number of a's factorial upon number of b's factorial. That means n factorial upon I factorial, n minus I factorial. This is the formula. So we have to generate this formula. Now let's generate the factorials. So before starting the question, let's create a function which generates the factorial. So this is a function which generates all the factorial. So I will say, let's create an outside variable factorial. Since n can be at most 10 raised to power 5, so I will say 1, 0, 0, 0, 1. So because these numbers, because n factorial, I have to go till n. That means I want till the factorial till n. Okay, void create factorial. This is a function that I'm calling. Let's generate all the factorials. Now, within that, I will say fact of 0 is equal to 1 because 0 factorial is equal to 1, you know. And 4 int I is equals to 1, and I will generate all the factorials. Now I will say fact of I, what is equal to I into 1, 1 LL into fact of I minus 1 modulo mod. Okay, and just this is the factorials that I've generated. Now what is NCR function? NCR function is above factorial, numerator factorial upon denominator. Let's say this is some numerator. Let's say I have n factorial and I factorial, n minus I factorial. And let's say I have this numerator. And let's say I have this denominator. Okay. So what I want, if I do modulo mod, then I can't do like this, as I already said, like numerator modulo mod divided by denominator modulo mod. I will say numerator modulo mod into denominator mod minus 2 modulo mod. If you don't know this thing, just try to grab it now because it can be useful in many competitive questions like numerator modulo mod, denominator power modulo minus 2 modulo mod. Okay, so I want this. So I will say, okay, NCR function is like this, NCR, and we have two variables, N and I. And within that, so what we have to generate? We have to generate n factorial upon I factorial into n minus I factorial, as I already said. So how can I generate it? I will say numerator is equal to fact of n because I have already done calculating these things. Okay. What is the denominator? Denominator is equal to fact of I into 1 LL into fact of n minus I because it may overflow because we're multiplying two big integers. So modulo mod. Okay. So this is the numerator and this is the denominator. So what will you return? Numerator modulo mod into denominator power mod minus numerator modulo mod into what? Now I will say I have to calculate the power. For that, I will create a binary exponentiation function which will calculate me the power. I will tell you denominator power modulo minus 2 modulo. Okay. Now, what is a binary exponentiation function? Binary exponentiation function is used, if you don't know, you can see like binary exponentiation function, if you don't know the trick, it's something like gives, let's say I have n, if I have power x, so it will give me the power in very less complexity for this answer. n power x. So I will say okay, binary exponentiation int n, and let's say I have number n, and let's say I have x. So what I will do, answer initially 1, while x, I will say if x and 1, then I will say okay, n is equal to n into answer modulo mod. Okay, basically I should do answer into n modulo mod, and n is equal to n into n modulo mod x left shift is equal to 1, return answer. So basically it can also exceed the integer. So we have to do 1L, and whenever there is multiplication I should add this as I've done. Yes, here I have not done because numerator is already modulo mod. I don't need to do it. I need to do complete modulo mod. Okay, and like that. So let's try to compile it in the code and check whether it's working fine. There are some errors like, okay, I have not declared the mod hash define mod int 189 plus 7. Let's compile it in the code. Yes, so let's try to submit the code. So yes, it's totally working fine. So basically, many submissions are taken. Like I have tried many times limit exceed tricks. But one thing that you have to understand here, that what I was doing, I was generating the combination first, and after that I was checking whether this combination is a best integer. If it is a best integer, then check all the permutations. And these above things are somewhat, if you have done already like these things, then this was all about code. So if you like the explanation, please like, share, and subscribe to my channel. Thank you and have a nice day.